Hello, everyone, and welcome. I'm Amber Mace. I'm the Executive Director of the California Council on Science and Technology, and I'm delighted that you can join us today for this briefing on grid resilience. I'd like to open our briefing today by acknowledging that I'm presenting to you from the tribal lands of the Nisenan people. Sacramento has been a gathering place for many local tribes for thousands of years, and we acknowledge the Southern Maidu people to the north, the Valley and Plains Miwok people to the south of the American River, and we'd also like to honor the Patwin Winton people to the west of the Sacramento River. I'd like to give you a little bit of context about who we are as an organization, our disaster resilience initiative, and some of our partners who are joining us today. And then I will turn it over to our moderator, Assemblymember Chris Holden, to take us into the conversation. We at the California Council on Science and Technology were created at the request of the legislature, which is one of the reasons I am delighted to have a legislative partner here as our moderator today. And we were created to be a connector, a translator, an entity that could bring in the science and technology knowledge and expertise that is created throughout California and beyond, and to help translate it into advice and information that our policymakers can use to make California's policies stronger with science. We do this in a number of different ways. We have briefings such as this. We place PhD scientists and engineers as science policy fellows in the legislature and the executive branch for a year of government service and leadership training. We produce peer-reviewed reports, and we think about how we can just better connect what the policymakers need with the knowledge that's being produced. We scan the horizon for issues that are emerging, and we also listen carefully for what the priorities are of the day. And today, we're talking about grid resilience, which is a key aspect of the disaster resilience initiative that we have launched as an organization. And I am so grateful to all of our partner institutions who are contributing to this effort. In particular, today, we get to focus in on our laboratory partners. We have 6 laboratory partners, 4 from the Department of Energy, including Berkeley Lab, Livermore Lab, Sandia and SLAC, as well as NASA Ames and NASA Jet Propulsion Laboratory. And today we get to highlight 3 experts from our laboratory partners. And if you would like to learn more about the incredible work that our national lab and our federal lab and research centers do in this state, I encourage you to click on the link that was put in the chat that takes you to a report that provides a lot of details, in particular about how our labs are helping California better prepare for, respond to, and recover from these intersecting disasters. And the incredible work that's highlighted in this report is really just the tip of the iceberg for what our federal labs and research centers do in California. And so I really encourage you to take a look, because they are producing innovative technology that's improving California and the nation's resilience to these disasters. They employ world-class staff and support hundreds of California's businesses through procurement and small business grants. So please do take a look at the report and let us know if you would like any help getting connected to them. So now, without further ado, I am absolutely delighted to turn this over to our moderator. I'd like to introduce our moderator, Assemblymember Chris Holden. He represents California's 41st Assembly District. He is the chair of the Assembly Utilities and Energy Committee. Earlier this year, we were delighted to honor him with CCST's Science and Public Service Award for his leadership as a champion of science and technology issues and his efforts to connect science and policy. Assemblymember Holden, please take it away.
Well, thank you, Amber, and I really do appreciate you and CCST for hosting the panel today. I appreciate the kind introduction, and I'm pleased to participate in a panel that touches on an area of such critical importance. But let me just start real quickly by saying I appreciate your help in identifying a really talented young lady who became our science fellow, spent time in our office and then in the Senate, and has come back to be our chief over the Utility and Energy Committee, our chief consultant, and that's Laura Scheibert. And the program is an amazing program that brings really talented people into the Capitol and gives us an opportunity to really draw from their expertise and for them to grow and to put more talent into this area of expertise that certainly the legislative body benefits tremendously by. So thank you for that role that you play, and I really do appreciate the partnership that we share. I was named chairman of the Assembly Utility and Energy Committee back at the end of 2016. At that time, the majority of energy policy discussions in the state touched on making our grid as clean and green as possible, and to do so with urgency. It is not that we have lost sight of that vision. Our state is well on the way to our zero carbon electricity goals. But most of my time as chairman has been marked by a series of catastrophic events. Wildfires, either caused by utility infrastructure or impacting utility infrastructure and reliability, as was the case with the bootleg fire in Oregon shutting down our major transmission line last month. High heat events impacting reliability as our grid is stressed from so much demand and some of our generation units lose efficiency in the heat. And of course, cybersecurity threats, which seem to be growing in frequency. All of these emergencies highlight the critical topic that the esteemed panel will be discussing today: how to build a resilient electrical grid. Before we dive into the nuances of that question, it helps to set the table as to what exactly we're discussing when we mention resilience. For the purposes of this briefing, we can simply think of resilience as the ability to prepare for and adapt to changing conditions and then bounce back from those disruptions. But that's a very broad definition. As my time as chairman demonstrates, how we define resilience is greatly tied to what type of threat or crisis is being discussed. So with that in mind, I'll turn to the panelists to have them introduce themselves and maybe add some more color to our understanding of what we mean by a resilient electric grid. First, I'll look to Mr. Hanley. You would be up first. I look forward to your thoughts and introduction on the question at hand around resilience. Welcome.
Thank you, Assemblymember Holden. Thanks to all of you for joining us and for the opportunity to join this group. Again, I'm Charlie Hanley at Sandia National Laboratories, Senior Manager of our Grid Modernization and Energy Storage programs. And I was recently having a conversation with a colleague about collaborative opportunities around resilience. And when this colleague asked what part of my program space addresses resilience, my answer was all of it. Resilience is a crosscut that we apply and employ in all of our thinking and all of our strategy around the technology areas that we're advancing our program space. I've been at Sandia for 33 years, 27 of which have been in our energy programs, starting out looking at off-grid applications in rural development, moving on to strategizing for our large PV systems, and then ultimately moving into grid mod and storage. And so using all of that degree, all that depth of experience and thinking about where are we going in terms of a future grid, there are a few priorities that programmatically we're focused on, again, towards this future resilient grid. And Assemblymember Holden did a fantastic job of laying out how we look at resilience and the importance of basically defining resilient to what and understanding threats. But we still need to come up with ways to measure and quantify resilience as we make decisions in our research and in our move forward. So that's one area that we're focused on. A few crosscuts in our research, very briefly, that I'll mention, and then we can go to others in discussion, are looking at advanced grid architectures and the meshing between distribution and transmission systems as we move forward, such that we can have more resilient or adaptive grid architectures. Power electronics and conversion systems associated with the grid of the future and more agility, as well as energy storage technologies at all scales, from seconds through seasons. And finally, advancing hardware and software development to be able to make decisions, provide controls and protection at all levels on the grid. So those are some of the crosscuts within our program area that we're working on. Thank you.
Thank you, Mr. Hanley. We'll just have the other panelists, if they could, self-introduce, and then give us your thoughts on this opening question around resiliency. Alyona, if you'd like to be next.
Hi, yes, absolutely. Hello, everyone, and thank you for having me on this panel. I look forward to chatting on resilience today. So my name is Alyona Teyber. I'm a staff engineer in the Grid Integration Systems and Mobility Group at the SLAC National Accelerator Laboratory. So our group within SLAC focuses on integration of renewable energy. Our motto is 100% clean energy for all, and all our projects really just dive right into that. To approach that, we do develop distribution grid modeling tools, resilient metrics, and electrical vehicle integration technologies that kind of all come together under this clean energy umbrella. So I am leading a Department of Energy Grid Modernization Lab Consortium project called GRIP, or Grid Resilience and Intelligence Platform. This project is mainly focused on using data-driven and machine learning approaches to resilience. So a lot of the focus is integration of these platforms with the databases that deliver the metric that capture vulnerability of these grid assets. So Charlie has mentioned one of the things that is really important is the quantification of resilience. And that is one of the things that we are focusing on as well on the distribution grid level. So our project is partnering with a number of electrical cooperatives. So it is a Department of Energy level project. So we have a lot of nationwide partners, as well as California investor-owned utilities that give us a lot of the insights as to where our focus on the project should be, which gives us a lot of opportunities to find a niche for our research and to really tackle the problems at hand. But yeah, I look forward to chatting further. Thank you very much.
Thank you. Jean-Paul?
Yeah, hi, thank you. My name is Jean-Paul, or JP Watson. I'm at Lawrence Livermore National Labs in, not surprisingly, Livermore. I'm a part of the computing division and also the global security division. My background is decision-making under uncertainty, in particular optimization. So all my degrees are in computer science, but I've been working in critical infrastructure and power grid resilience and reliability for about 12 years now. My view of a lot of this is, Charlie mentioned they had a good setup for what's important to the resilience space. I view it as everything is driven by the threats that you care about. So for example, right now, I'm the wildfire lead for DOE's North American Energy Resilience Model. We are looking at forecasts of where active wildfires are moving and also where new fires might start. Trying to computationally characterize that. And then we use that information to do simulations and kind of try to understand, are certain events more likely to have impact than others? For example, bootleg is a huge impact because you have a lot of lines coming down there. Dixie Fire, as big as it is, actually isn't near a lot of large infrastructure. So it's not very impactful to the energy system, not to say that it's not impactful to the people on the ground. So that's kind of my view there. Metrics and quantification is super important, especially since I view everything as an optimization problem. So I need some metric to say I'm doing better than either current state or the best possible. So trying to quantify resilience and what does resilience mean is really critical. And there's been a number of studies that I've been part of that started back, I think, 2012 there. The key thing to note there is, if you look at measures of reliability, impact to people or industry or something policymakers care about, that's an impact. So consequence measures are important, and I think there's a lot of work to be done in that space. I'll stop there. Thank you.
Well, thank you. I appreciate all three of you, your take on this issue around resiliency and your particular lane of expertise. And so that really does get us off to a good start. I know we've already highlighted some of the challenges of our grid, which our grid faced in recent years. So I'm hoping you might address what some of the available pathways of increasing resiliency might be moving forward. And please be specific on which threats these pathways are addressing, or even better, highlight where certain solutions may be leveraged to address multiple threats. Charlie, would you like to, and why don't we just, if it's helpful, unless you want to just jump in right away, we'll just go in the order that we started in, and then you can all kind of give your point and thoughts on the question.
I'm happy to, although I won't be so bold as to be the first person to jump in with each question that you ask. Okay. But I'm happy to start off that way. That's a great broad question. And so there's so many different ways that we can answer that. And I think we actually should try a little bit of discussion around that. I'll start off by saying that what I said about flexible grid architectures are a few words that convey a very broad concept. And so if we can think about a grid that can actually, based on the threat and based on the magnitude of the threat, be able to segment in real time into various islands, perhaps, where we have different scales of microgrids. And again, energy storage technologies that are available that allow local generation to be used for extended periods. That kind of construct, or that kind of future infrastructure, would allow a resilience to some number of threats under different circumstances, such as impending storms, such as perhaps impending wildfires, even cyber or physical based threats, because it would basically provide some level of local autonomy. And so there's a whole amount, a large amount of research necessary and technology development in order to make our grid more segmentable in that realm, including market and policy structures. It goes way beyond technology, but I do think that we have the opportunity, and business models, frankly, for utilities and such businesses. We do have the opportunity to really explore moving forward a far more agile grid infrastructure at varying scales. And in fact, using tools that all the labs are developing, including what JP referred to as the North American Energy Resilience Model, to demonstrate scenarios where that might be viable. I'll stop there for now and let the others chime in.
Thank you. Jean-Paul?
Yeah, I'll take a slightly different dimension to this. In my mind, there's two technologies that are, two spaces that you can make decisions that actually will improve resilience. One is you can pre-position and kind of anticipate what's happening. There are two ways you can improve things in the kind of anticipatory realm. One is you can do projections of what might happen, do simulations and understand the impacts, and operate your system differently to basically recover better from those impacts. Resilience is all about, as Charlie said, kind of alternative pathways. So, if you only have one way to get Bonneville Power Hydro down from Oregon to California, and that's through the Bootleg fire, that's not very resilient just because you got one pathway, it's a high wildfire risk area. So, when you actually are doing planning, and this gets back to the metrics, you need to start thinking about resilience objectives, not reliability objectives. So when they built that, they thought, this is cheap, minimal cost, we're still reliable to the loss of one component, but they didn't think about the wildfires. If you start thinking about resilience, and this has a lot to do with correlative failures, failures that happen a lot, many failures in the same area, which of course happens for wildfire, but also polar vortices in ERCOT recently, for example. One natural gas pipeline takes out a large number of thermal generators. Those kind of correlated outages are what you need to plan for, and that's not what's being done currently in practice. So in my mind, that's the most critical part of making a system resilient, creating alternative pathways by acknowledging the fact that you need to understand these correlated failures, you need to anticipate them, and they are realities, so that's how you address them.
Thank you.
The one thing I want to kind of touch on that, JP, you've actually made some of the point that I was looking to make in terms of the civil planning. I think it's very important to look at communities, the way they expand, and think of resilience as one of those variables in regarding expansion. A lot of the planning kind of happens radially out from the city. However, the electrical resilience, wildfire resilience is not necessarily taken into account, specifically with additional electrical loads and expansion of the distribution grid. That is something that really needs to be captured prior to expansion of the actual residential and the commercial infrastructure. If there's certain communities that are quite vulnerable, and especially to the wildfires, as we know in California. And the things that we don't necessarily take into consideration right now is whether putting in distributed energy resources such as batteries or solar panels is really beneficial if a wildfire is sweeping through that area and all of that pollution gets released into the area, or whether there's exit routes for the community that exist that can safely exit the community from the area if there was a resilience event.
Yeah, a quick follow-up to that. I think it's important to note that with resilience metrics, there's a lot of data, like the labs as a whole have a lot of tools for creating resilient systems via investment planning and capacity expansion. What we don't typically get from ISOs, utilities, are metrics and data quantities like equity and environmental impacts, even priorities of buses. Like they view things from a transmission level. We're going to try to minimize loss of load at these particular buses. There's not much visibility to what's behind the bus, what you're serving. So exactly what was just discussed is, like, if we were able to get more data regarding equity measures, environmental measures, that's critical to get us to resilience targets. So I think policy and decision makers really need to think about, when they say resilience, what exactly do they mean? That's still fuzzy despite DOE talking about it for 10 years. And there's no widespread agreement on that. But until you have agreement on that, it's hard to know if you're resilient, because you need to understand what that actually is.
No, I think that's a really important point. One of the things that I wanted to shift for just a moment within this line of thinking is around cybersecurity. I know that it's becoming more of a challenge. We're obviously concerned about it. We don't talk about it a lot publicly through our committee because obviously for obvious reasons. But I think it's important to sort of understand what resiliency looks like in terms of protecting the grid from outside attacks. I know the focus on which are very much right in front and center on the natural disasters and the challenges that poses in terms of resiliency of the grid and being able to perform under those challenges, how climate change is really just causing high heat events and things of that nature. But we are also seeing in recent times that we can also be vulnerable to cyber attacks that would challenge the resiliency of the grid. Any thoughts on the pathways that you've described and how that might apply, or does that open up a whole nother set of pathways that we'd have to explore?
I had some thoughts on this. If Charlie, I wasn't sure if you were going to jump in.
Feel free.
Okay. So we do a lot of, like I mentioned before, modeling of threats. So I think it's absolutely critical. If you think about natural threats, you can think about a hurricane coming in, and you can use historical data to kind of predict where particular lines might go out because the wind speeds, went over a certain threshold. Intentional threats like cyber and physical attacks are a much different beast to model. Especially with cyber, you kind of need to assume, if you have an intelligent adversary, they probably have the same models you do, and they can do some analysis of that to identify what actually matters to attack. So what are the critical components in the system? So I think when you talk intentional threats, think about criticality in a very different way. You have intentional actors, they can identify things that a natural threat wouldn't ever manage to manifest. So we spend a lot of time we have tools that are able to do that kind of identification. The other thing I wanted to say on the intentional threat side is there's this kind of reaction that they need to protect everything, right? So somebody might say we need to stop our DERs from being, able to be disabled or messed with by a particular adversary. And that's great, but you really need to understand, are they actually at critical nodes? You need to actually spend that effort to harden that particular system, because if the nodes aren't critical, or if those components aren't critical in the overall system, then you shouldn't spend money there. So I think these kind of modeling of and understanding where you have critical components in the system is absolutely necessary in order to guide investments and get maximal benefit for cyber protections. So I'm not of the knee-jerk. I'm not of the opinion where everyone should say, protect everything, lock everything down. That's not true. There are going to be a couple of critical systems, and you should focus on those. And we have analytic tools to do that.
Wonderful.
If I may, I'll add a broader comment. I concur with what JP is saying. Even in the context of what we were saying earlier, there's different timescales to be looking at. Everything that we're talking about applies either as you're planning for the future and planning out modifications or investments on the future grid, or you're thinking about operations and making decisions in real time or near real time. And so this applies to cybersecurity as well. And I think it's a really challenging issue, challenging set of problems around getting the right kind of data and understanding those critical vulnerabilities. There's also an aspect in terms of cybersecurity where it's a common problem because access through one utility or one part of the grid might lead to an attack in another area. So there's a need for a lot of collaboration and communication. I'll just pile on what JP said in the sense that we are indeed looking into the proper kinds of tools to be able to assess criticalities, looking into modeling and even hardware-based experimentation around cybersecurity for critical nodes and critical systems on the grid. Though I'll admit that it is a very challenging set of problems that we're currently working on. And partnership, I think, is the most important aspect of making progress in this arena. One element of that is working with currently the National Rural Electric Cooperative Association in working to develop a cybersecurity trained and enabled workforce around rural systems and those grid edge and distributed devices that Alyona is referring to.
It's also worth pointing out that getting data for cyber, so there are, we have models of the transmission system, distribution systems, those are relatively easy to access. What we don't have are kind of the operational technology, the overlays, the cyber overlays on top of those systems. So whenever we've been trying to get into that space and actually do this critical component identification, we often have to kind of, I won't say make up, but using our best guess heuristics based on domain knowledge, augment that to the system because that just isn't available from the operators. And often the utilities and operators don't even have that information to be able to give to us. So there is even though we'd like to be able to make things cyber secure, I don't think we have the data of sufficient fidelity to actually drive the models currently that we have.
Well, it sounds like we're continuing to evolve our thinking and how we can be in the best position to create greater security and reliability and resilience to the grid. And as I heard you describe, working in a collaboration and continue to focus in on strategies are going to be most important. So I appreciate all the great work that you're already giving and the attention you're giving to that area. I was also hoping we might touch on how we ensure at-risk communities realize the benefits of these grid resiliency investments. One of the focuses of my legislative career has been ensuring equity in all aspects of public policy. So it is a particular concern for me that these investments benefit the communities most severely impacted by poverty and pollution and changing of the climate. Alyona, would you like to give us your thoughts in this particular area?
Yeah, absolutely. I think what you're mentioning regarding equity really ties in back to the metric. So some of the approaches that we've looked at is essentially taking in a number of different data sets. And when I mean data sets, I don't just mean distribution network models or load data. I also mean things like census data and ways of essentially quantifying equity around the grid and putting all that into the metrics. So kind of creating this wholesome approach to the metric rather than just a technical approach. So I think that's one way to approach the equity question, is to really just get your hands on as much data you have about how a particular community stands, whether it's able to afford renewable resources, whether it can afford residential resources, whether it can afford community level microgrid resources, how their load plays into the effect as well. So a lot of the talk in California is the electrification of appliances and things like that. However, some communities are not able to take that approach, and that is something that really needs to be captured. And the way we are approaching is, like I said, is through a resilience metric.
Wonderful.
May I add to that?
Sure, please.
That's a great way to lay the groundwork. I believe that's really important. We've been working with several other laboratories in a few different places to develop a metric that we refer to as social burden, and it comes out of the social sciences, frankly. And it's looking at, just as Alyona was referring to, it's looking at the costs, the collective costs of individuals getting to the resources that they need to get. In other words, the burden. And those resources can be food, healthcare, gasoline, police or fire. So in a community, the collective burden basically of getting to those resources, and then looking at different viable pathways towards keeping those resources available. If we're looking at the threat of a storm in Puerto Rico and flooding associated with that and power outages, we can actually then look at different microgrid configurations or locations and come up with an optimal microgrid set of microgrids to provide the lowest social burden in that kind of a case. So it's a very good way to look at what Alyona is talking about in terms of community resilience and also equitable assurance of services to populations in a number of places.
I want to follow up briefly on both points. To me, the biggest issue in terms of getting these things addressed in practice is just the focus of how things are operated right now. If you look at what ISOs do, they are minimizing costs because that's what they're set up to do. So they're going to minimize overall production cost. They don't, if there's more pollution generated in a particular area, unless there is some kind of constraint or unless there's some kind of imposition in the model that they're doing to address that, it's going to happen. So you have to look at the incentives of what the ISOs are doing when they operate, because I think unless you change those, that's not going to bubble down to the lower level. And people optimize, including me, what they are given for metrics. So you need to go, in my opinion, to the operators, and once they start to understand and integrate this information, you will have a more equitable distribution of impacts. Same thing with prices. When they clear the market, there can be some nodes through no fault of your own, your hub price might be super high, not because of anything you did, you just happen to live there. So a lot of that kind of distribution of costs and impacts just isn't considered because it just isn't considered right now. It's not one of their objectives.
Well,
Excellent point. Oh,
yeah.
Just quick follow-up to JP, if I may.
Sure.
Excellent point, and that's why we've had, in terms of pragmatic demonstration, maybe some greater level of success in a place like Puerto Rico, where there's this discussion about what happens if we can start from scratch or rebuild or redefine how that grid is being operated. And similarly, working with the military or campuses and identifying what are those critical assets and the mission critical areas within a campus or a military base, where again, the social burden type of construct can be applied, such that we're blending actually ordinary operations as well as resilience operations. And we've been able to gain some ground in that realm because of the concerns or difficulties that JP points out.
Well, I'm also taking a read from what you're saying, in that as a policymaker, making sure that we're keeping in mind of that and connecting with the IOUs and operators as well to make sure that they're looking at this and getting the information in a way that they can be most effective in addressing the kind of outreach that I think is going to be necessary. I'm going to pivot to the audience questions. We have a number of questions that are coming in, and I thought I'd look to that now. And the first would be from Nathan Spangler. He's with Cal OES. Question is, what partnerships and sharing of the predictive models is being done with CPUC, California Utilities Emergency Association? And whoever feels comfortable jumping in on that one, go for it.
I wish I had a good answer. I don't.
Yeah.
To be honest. I can say, for example, for the North American Energy Resilience Model, which Charlie and other labs are part of too, we are building up these capabilities. We're trying to get the tools in one unified interface that others can use. People like NERC and FERC are starting to get access to those. We're trying to bubble it further down, to local entities too. It just hasn't happened yet. So I think right now it's more of a function of lack of communication channels than anything else from what I've seen at Lawrence. Once we get the relationships made, I think that would happen relatively quickly. We at the labs are more than excited to give our tools to people and help them use them. We just need those connections.
I'll offer the, oh, sorry, Alyona, if you want to speak, go ahead.
Sure. I just wanted to add that, so our focus is mainly on the distribution side. So the collaborators we've worked with are the California investor-owned utilities. So we are currently trying to deploy our tools with Southern California Edison. We also have deployed our tools with the cooperatives nationwide, not necessarily in California, but otherwise. So it's a challenging process, and it kind of ties back into this cybersecurity question of maintaining the data and maintaining the platforms, and kind of the transparency has been one of the challenges that we've had with what the California IOUs are facing versus how we're trying to deploy our tools. So one of the things we are finding is important is kind of the standardization of the approach of modeling, because there is a bit of a disagreement about how things are being modeled and used in particular. So that's one of the challenges that we're trying to overcome at SLAC.
Thank you, Alyona. If I may, I'll offer a slight spin on the question in that our energy storage program, there's a significant and growing effort currently around demonstration projects. And that's demonstrations of different storage technologies as they're coming into commercialization in different applications and at different scales. So if you kind of map things out in a matrix, that's a lot of different possibilities and types of applications that we, the broader community, stand to learn a lot from. With California being a leader in terms of storage demonstrations, we have a relationship with the California Energy Commission. And through that, we spend time interacting with the PUC as well as the utilities in helping to define those the beneficial applications and types of projects in terms of technical and performance specifications, as well as data generation. Then what kind of data do we want to be able to track in order to assess not only performance, but also value that comes from energy storage in these cases, because there's so much that we really need to learn in that regard. So we've had some pretty darn good collaborations and intend to continue in that realm.
We're excited about storage. It's all about technology. The more we get advanced and go from 3 to 4 hours to 3 to 4 days, it's a game changer. So no doubt. Our next question, where are our most pressing gaps in knowledge? What are the biggest barriers to building a resilient grid that remain to be addressed?
And for knowledge, I would say two things. One is, as I said before, cyber overlays, cyber information of current systems that go with the power flow models and the natural gas models, for example. That's a huge hole if you want to address intentional threats. I think a lot of the equity, social justice, environmental metric data is available. It's just not as routine integrated into the tool sets that we have. So I think a lot of that is probably an issue of standardization and just socialization of the data sets that are available. And also, frankly, which data sets people, policymakers trust. I think, especially in that kind of data, that's a critical aspect that we need to resolve.
Yeah, I would say availability of data is one of the kind of the missing pieces, especially kind of the contrast to reliability. Resilience has much less data available. So if an event happens, it's going to unfold in a very different way every time, more or less. So it's very hard to validate our tools in a way that is going to have the same kind of what I'm trying to say is if you have a number of different events and you don't have a large quantity of these events to validate your tools on, it is very difficult to kind of convince others to deploy and use the tool if you can only respond to the events that have already happened and follow a similar track.
Actually, I had a quick follow-up on that. That's a really good point. A lot of the fragility, like when we're trying to model a particular natural threat like wildfire, a lot of the data that goes into that, it's a machine learning process. So you need big data to actually drive and understand what components might be outaged. But often we don't have that big data. And even if you get from a particular utility, 20 years of historical outages, trying to understand what the conditions were when those things were outaged, often it depends on who's on the ground and who's trying to fix it. Often the data is missing. It's just really noisy. And I feel that utilities and operators just aren't collecting that data because they haven't seen the neat tools that actually ingest it and give them value. So I think we're at the phase now where we think we can do that. We just need to, they need to start making a lot of the failure data under these big events much more available to the people that want to give them the tools.
I'll just add that just this morning, I was tasked by the U.S. Department of Energy to spend the next month answering this very question. So it's on the minds of a lot of people. I think that the path forward is going to depend equally on technology, policy, and even business advances that lead to more resilience.
Let me ask you this. That might tie in a little bit. This is a question that is coming up here. Who are you partnering with at the federal, state, and local levels? You may have touched on that a little bit, but be helpful to hear what your thoughts are on your partners.
For the North American Energy Resilience Model, there's a partnering with NERC and FERC in particular. So, those are critical. More locally, as has already been said, we have research projects with Cal ISO and the SC&E, PG&E, things like that. Doesn't go much, at least for Lawrence and the projects I'm working on, much below that. So I'll stop there.
It's such a broad question.
Yeah.
At the federal level, we're certainly partnering with Department of Energy, DHS, Department of Homeland Security, and Department of Defense in really looking at where to apply resilience. JP already mentioned FERC and NERC and organizations such as that. Yesterday, I was in a hearing with the New Mexico State Legislature because resilience is very much of a state concern. And I think we're going to see other states really delving into this further and further. So we're just partnering across the board. I think the private sector is very, very important. Utilities and suppliers and manufacturers, because supply chain will end up being a very important aspect of maintaining resilience and security of our future grid. So it's a broad question. We need to be generating partnerships and maintaining them across the board. Academia as well for workforce development.
You mentioned, and I guess this question, Charlie, is for you. Earlier, you mentioned gaps in market and policy structures that could also advance resilience. Could you expand on what those might be?
Actually, I think JP is the one who mentioned gas when he was talking about the polar vortex. But it's really very important for us to be looking at the interdependence across these infrastructures. So the advances in, let's say, developing resilience via hydrogen, using excess electrons from renewable energy to generate hydrogen and then putting it into our gas system and our gas pipeline system. We need policy and infrastructure development around making something like that viable. That's an area that we're exploring within the state of New Mexico across many organizations. As well as water systems. I mean, I'll just expand from gas to interdependencies among infrastructures. We've really got to be exploring that. Communications, transportation, and the electrification of vehicles. How all of this comes together and affects, if we don't plan for resilience, we could be negatively impacting resilience of these infrastructures. JP, would you like to go further? Or I'm sorry.
Yeah, I'd like to follow up a little bit on that. Yeah, in my mind, a really good point is market designs right now are focused on reliability. There's no price for resilience, and therefore, it's not being built out in order to accommodate that. If you think about capacity markets, there are analogous markets one could use to clear to ensure that you have a resilience metric of a certain target achieved. Those just aren't in the process and the flow for what happens in terms of investments. So I really think you need to start pricing resilience and have a market for it and understand what the thresholds you need, want for the resilience. If you want I'll throw out numbers like if you want 99% versus 99.99, it's going to cost you this much more. So you need to understand how to set that, but then also you need to understand the prices required to get there. And that's what a market does. And that's what we were massively lacking. And that, of course, also drives the fact that it's hard to get resilience investments justified at a PUC level, because if there's no price on it, it's just arguing, in text and verbally about, yeah, we need to put an extra line here because of this. Well, if you have metrics and, every other type of supporting analytics that goes with that, then it's very easy to justify that investment.
One of the things that, and we're going to have a hearing, our committee is going to have a hearing later on today to talk about decarbonization. And, Charlie, you mentioned the issue around hydrogen, and we're sort of obviously looking at natural gas and moving in a different direction. But until we have something that is cost effective and reliable and efficient, we're sort of stuck with what we're at. So in all of the conversation around resiliency, as policymakers, we're also trying to make sure we're staying on course with meeting our renewable goals and how to address the issue around natural gas. And hydrogen has been part of that conversation. I know this is maybe a little bit off some of the topic, but as we try to make sure that, and I'm thinking about where we have storage of natural gas and the resiliency and making sure that it's available and there's adequate resource use. How do we start to, in your mind, just to taking advantage of the fact that we're having this conversation and then just sort of broadening it a little bit, how do you see us integrating, or do you see hydrogen as the kind of source that makes for decarbonization transition better way to go? And I know we're still exploring different options on natural renewable, but do you have any thoughts on that as a way to address not only our resource needs, but also how that can help us in terms of making sure the infrastructure is in place to provide some resiliency around that particular asset?
I think you have laid that out so well in terms of the potential of a future where hydrogen can be significant in making a transition to clean energy, and also many of the challenges associated with that we're facing right now. So I do think there's a future for using hydrogen in our infrastructure in a large way for storage, for fuel conversion from fossils to cleaner fuels. But I do think, and actually there are some really interesting pilot examples in Utah and New Mexico where people are really looking into hydrogen generation and storage and hydrogen transmission. So lots of challenges, but I do see it as a viable transition approach.
Appreciate that. We talked a lot about the data gaps. What are some of the other barriers to building a grid resilience that we have to contend with? You may have touched on this in some of your other answers, but a question that came through.
Biggest issue, to be honest, is legal. And it's just trying to get information, as DOE, a lot of the models try to focus regionally. So we're gathering information from a bunch of different pipeline operators, a bunch of different utilities, ISOs. There's market data that's sensitive for, economic reasons. There's CEI data, and there's, getting the legal agreements in place to allow one to develop models that even cover a relatively small region just takes a huge amount of work. And like on the North American energy resilience model, that's been a focus for the past 2 years, and it still isn't solved. So I hate to say it, but a lot of it's legal, but it's important because you can't develop these kind of models without resolving those kind of problems. So streamlining the sharing process would be invaluable to everybody.
Any other thoughts?
Alyona, I'll let you jump in if you care to.
I don't have much else to add. I think data is a big one, so I'll leave it at that.
I think there are a number of technology pathways that we could be exploring. I like to think that innovation will help us, and of course, data and the legal challenges of getting to data are very important. But I really think that we're on a path to significant technology innovation, new developments around power conversion, energy storage, control systems, where we can really enable U.S. industry to really do more clean manufacturing in domestically. And so while I concur with both Alyona and JP, I really do want to keep technology innovation and technology development in our sites.
And I'll expand on what Charlie said, was a good point about technology. Expanding that to include software and operations, I think is important. Generally, power systems operators are a very conservative breed. So, sticking the latest and greatest machine learning technology in there generally makes them nervous, and for good reason. They have to keep the lights on. But there's a lot of space and a lot of technologies that are being developed right now that could definitely be applied, and in academics and national labs are being applied to power systems operations and resilience mitigation, but they just aren't making it into practice yet, partially because of a cultural barrier, but also just the conservativeness of the operations.
You talked about the importance of characterizing resilience to specific hazards. With the frequency and variety of threats increasing, how can we account for the ways different disasters might interact and compound?
Good question. So I'll say from the cyber standpoint, like I was mentioning before, we have methods where you can take system models and identify critical components. Those technically are agnostic to attack, right? Or the source of attack. However you disable a particular component, be it, fire or an earthquake or whatever, it's still critical in the system. So a lot of those techniques are generic in that sense. So that's one thing I wanted to say. There is quite a bit of work trying to understand correlations, for example, between wildfire and earthquake in California. Like, are the hot spots, do they overlap? And then once you have that overlap, can you actually understand, using some of these vulnerability detection methods that I mentioned, what are the hotspots in there that actually could be impacted by both different events? There's been less work done on coordinated natural and intentional threats. So for example, if you wrote a Tom Clancy novel, you might come up with the idea that you were wildfire going, you could observe what bootleg did, and once bootleg did it, you could actually initiate a cyber attack following that, knowing that you already have cut the reserves coming in from Oregon. There's not a whole lot of modeling there, but I think that's pretty rich for exploration. I'm not sure. It's one of those things where it seems so far out or far-fetched, but in my mind, that's probably a more critical area coming up soon.
One of the things I want to add in terms of the compound events is something that we've looked into where, so for example, a wildfire makes a change to air quality, and that actually affects the solar panels. And so how do you, for example, mitigate that, whether that you have a reduced capacity in solar given a wildfire? And these are some of the things that keep happening and keep happening more frequently. I think a better way to look at resilience is kind of this new normal approach, is that these events are going to be something that's part of our regular lives and that we have to adapt to them. And as these happen, the compound events are going to keep happening, and all these auxiliary effects are something that really need to be captured in the metric that we keep talking about.
Let me ask you this. I know from my vantage point, being in a policy position, we have the need to write legislation to address our current situation and to engage with the regulatory agencies to make sure that they're in the strongest position to address the resource needs, but also the resiliency issues. And I can tell you that since I've been chair of this committee, and I was in my opening statement, and I probably didn't put a fine enough point on it, it just seems like every year the climate change raises the ante. The drought conditions that we're experiencing here in California raises the ante. And then with high heat waves that are not just impacting California, but the entire Western states, which impacts our ability to import power when we need it. And we talked about the fire on the Oregon border and the transmission impact there. So are we going, and I know technology plays a major role in how we can then start to create some distance between how fast climate change is impacting on our lives and how we can be in a better position to be prepared. Do you have a sense of, just in terms of the overall movement of the information and technology, and that we are going to get to a place where we can start to see the advancements kind of kick in, and we can get a little bit more integrated into how we are preparing and addressing grid reliability and also resiliency, and not find ourselves kind of going from moment to moment? Even our forecasting and planning and modeling is just sort of changing so quickly. Last year, rolling blackouts kind of put us in a place where we hadn't been in a very long time. And so the directive went out, we're not going to be there next year. And as we planned for it, for August, like we had the impact last August, it all got accelerated to June. So it just seems like everything seems to be happening quickly. So I guess all that to say, do you feel that the data collection, the information, the technology is happening in a way where we can start to get better ahead of what the impacts of climate change is having on our way of life?
Yeah, there's a lot of work at the labs. Lawrence Livermore just initiated a project in this area trying to understand climate impacts on infrastructure. Generally, we think of weather. We'll take a particular weather year, current weather, and we run the simulations based on that. But of course, what we care about are, to get in front of climate, we need to know, like you said, how does load change due to heat over time, like in 10 years, is going to be significantly different. Are the locations of the wildfires going to be different? Are they going to be more intense in one area versus another, which means you might not want to put lines in that region where you think it's going to actually get worse. Factors like that. So we are starting to develop climate models as Department of Energy labs, complex, that actually start to address that, so we can project out 10, 20, 30 years, understand how both the load and the natural threats actually are likely to change. And then we try to plan subject to that. So I think those are key inputs to expansion models that are being developed. You're talking, 2 to 3 years out before those are available for pilot studies, but at least the effort is starting to kick off.
Well, I'm going to say this because we have to wrap up, and I appreciate that. And I'm going to hold you to that. I'm going to rely on all of you bright minds to sort of figure this out for us. I really do appreciate all of you as fantastic panelists today. And thank you for your contribution to this conversation. Amber, I'll turn it back to you.
Thank you, Assemblymember Holden. I am so grateful for your leadership on this topic and your moderation today, and to our panelists, Charlie, JP, and Alyona. Really important work that you're doing, and thanks for taking the time to share your insights with us. Thanks to everyone who attended. I also want to thank our CCST staff team who make this possible, in particular, John Thompson on this briefing. And if you didn't catch the whole briefing, it has been recorded. It will be on our website. There's a one-pager that summarizes some of the key takeaways, as well as has information about how to contact our experts. And please take a look at our lab impacts report. So check out our website. Again, thank you all. Keep an eye out for future briefings, and have a lovely day. Bye-bye.
Thank you.
Thank you.
Thank you.